Number 35. So it's a proof question. Start with your statements and reason. Make a T-chart, and then we're going to talk about how we write a formal proof. So the first statement will always be your given. So copy this whole entire thing, which I already wrote down, and that's your first statement. And the reason for it is that it's given. Your last statement is usually the proof. This is what you're trying to prove. Right? You're proving that these two segments are congruent. So on my picture, if I look at this, I'm trying to prove that this segment is congruent to this segment, right? So you'd think like, let's try prove these two small triangles are congruent, but we'll see. We don't have enough information to prove these two triangles are congruent. So instead, we are going to start with proving this triangle DCE is congruent to AFB. We're going to start with that. So let's see if we have enough pieces of information to prove that these two triangles are congruent. So let's get started with our given. It says AB is congruent to CD. So to show congruent, I put tick marks. So I'm going to put tick marks. AB is congruent to CD. That's how you do it, right? That's one piece of information. It's also parallel. Parallel lines make what kind of angles? Alternate angles. If I was to trace it, I'm going to trace it in green. So if I was to trace, you start at a parallel line, go down your transversal, and end at a parallel line. Do you see these little corners? Right? That's up. That's where your angles are. So that's in your second piece of evidence. And now I'm just going to erase the Z. And now what else is given to us? It says BF and DE are perpendicular to the diagonal AC at F and E. It means what? Perpendicular lines form what? Right angles or 90 degrees. So there you go. I have three pieces of information. And which congruence criteria is that? That's an angle. So it's angle. I'm going to go in the same order. That's an angle. And sides. So angle, angle, side. And I can prove that these two triangles are congruent. Okay, so we proved that two triangles are congruent, and we wrote out all our statements and reasons for our two triangles, right? And we proved that they're congruent by angle, angle, side. So now, next thing I want to do is, just watch this. I know segment AF, and I'm going to trace them. This segment AF is congruent to segment what? CE. So can I write about that? Right? Segment number 5, AF is congruent to segment CE. Yep. Right? Because these were in those two triangles. So by CPCTC, which means corresponding parts of congruent triangles are congruent. Right? Now, watch this. This segment EF is congruent to what? Itself, right? So let's write about that. Statement number 6. EF is congruent to EF. Anything that's congruent to itself is reflexive property, right? Now think about this. If I take my AF and I subtract, I'm going to erase this so that you can see it clearly. If I take my AF, this is my segment AF, and I subtract EF from it, I'm going to take this out. What am I left with? AE, right? And similarly, if I take my segment CE or EC and I subtract again this part from it, what am I left with? FC. Isn't that what we are looking for? So that is called the subtraction postulate because we subtracted from it. So statement number 7 would be, I'm just literally taking it from here. So AF minus EF is going to be congruent to segment CE minus EF, right? And when we subtract them, that's when I get AF minus EF is AE is congruent to CF. And I know it's a little odd to end on this, but that's called the subtraction postulate. that's one way of doing this question. There are many other ways too, right? And you can do it that way, but I like, this is what came to my mind, and I thought this was the easiest thing, like, you know, working off. So I hope that helped.